Hello friends, today's question. In the circuit shown, switch S1 is closed at time t is equal to 0 and switch S2 is kept open. At some later time t0, the switch S1 is opened and S2 is closed. The behavior of the current I as a function of t is given by. So we are given a RL series circuit and we have two switches S2 and S1, and EMF or battery source is represented as E. So we have to find out the variation of current I with respect to time t. So in this case we have two cases. In the first case, S1 is closed and our S2 is open, and in the second case S2 is closed and S1 is open. So we have two cases. Case 1, and which gives us that switch S1 is closed S2 is open, and this is from t is equal to 0 to t is equal to t0. The second case, switch S1 is opened and S2 is closed, and this is for t greater than t0. So let us consider these two cases. So we start with case 1, and in this case 1 our S1 is closed and S2 is open. So the circuit can be represented something like this. So I have this as a resistance, inductor, and we have a source, and this source switch is closed now. So this is our S1, this is our R, and this is our L inductor, and source is represented as given as E rather. So under this condition we have a series RL circuit. RL circuit. So we can write an equation for the, or we can simply use the Ohm's law and write the voltage equation. So you can say the voltage across the inductor L and resistor R is given as so we can write the equation V is equal to, sorry, it's not V, rather it's E is equal to L di upon dt plus I multiplied by R, where this I is the current flowing in the circuit. And we can find out, or we can say, we can also write the direct equation of the current from here. So we can say the current I of t will be equal to V upon R 1 minus E, and here we have minus T upon tau, where tau is the time constant. And this is written as L upon R. So in this equation, you can clearly see that the current rises from t is equal to 0 to maximum value V upon R. You can say this equation, or rather we can say equation 1 describes the current rising exponentially from 0 to its maximum value, which is represented as V upon R, with time constant L upon R. With time constant tau, which is our L upon R. So rise in the current is from t is equal to 0 to maximum value V upon R, and from here we can say that current start from t is equal to 0 to t is equal to t naught. So from the first part, we can at least say that option number A and D cannot be the correct option, because the rise should be the exponential. So the only option, correct option we are left now to choose is from B and C. Now let us write for case 2. In case 2, we have a switch S2, and we have our resistance R and inductor L, and this case it is closed S2 is closed at t greater than t naught. S2 is closed for t greater than t naught. So in this case, there is no voltage source in the circuit. So therefore, we can write the equation that 0 is equal to L di upon dt plus I multiplied by R, and from here we can write the equation for the current that our IT will be equal to this will be IT, and we have here I t naught e raised to power minus t minus t naught upon tau. So this is the value of the current at time t naught. So we can make a comparison between the two equations. Let us call this equation number 2. You can write from equation 1 and 2. From equation 1 and 2, for t greater than equal to 0 but less than equal to T naught. The value of the current is IT, which is given as V upon R, and 1 minus E, and this is our minus T upon tau. And for T greater than T naught, we are given the equation as IT, which is our V upon R, and this comes as 1 minus E minus T naught upon tau, and we have here e raised to power minus T naught upon tau. So we can clearly see that the decay is also exponential in the second part. From here we can say that the current decays exponentially. Therefore, the correct option is only B option, because in C there is a linear decrease in the current, so this cannot be correct option. So you can say option B is the correct option. Option B is correct. So this completes the question. Thank you.